Now, at the end of your pre-PCR, after you mixed your sample of RNA, DNA, plus primers, plus nucleobases, and and after you ship it to the thermocycler, between two different applications, you've got to clean your enclosure to be sure that the previous prepared samples do not contaminate your new samples. And that can be done thanks to two technologies. The first one is the usage of UV lights. And the UV lights that is useful for the decontamination is what we call UVC, or germicidal UV. When you talk about UVC, it means that the wavelength is centered on 254 nanometers. It's also very important to be cautious about the wavelength of your UVC bulb, because you must not generate ozone, and ozone is generated at 185 nanometer rays. So it means that your provider of PCR workstation must guarantee you no release of rays at 185 nanometers. And so to come back to UVC, UVC waves at 254 nanometers affect RNA and DNA and degrade them. So it means that after the destruction of DNA or RNA, thanks to UVC, you're sure that it cannot be amplified again. So it's important to use the accurate wavelengths, but at the same time, you must use the accurate wavelengths at the accurate dose. And what we call dose is intensity, the intensity of UVC that is linked to the amount of wavelength of light that is generated on your worktop. So it depends on the UV lamp, the distance between the UV lamp and the worktop, and the way it's also distributed into the chamber, into the enclosure. And it's also a function of times. And that's the reason why all Captair BIO SMART are equipped with a timer that allows the user to adjust the decontamination time. I told you that there is another way to decontaminate the internal volume of the enclosure. That's thanks to cleaners. I just want to focus that if you use cleaners, you must be very careful about the type of cleaners, because they must not degrade the material of the enclosure. As example, if you think about stainless steel worktop, they can be damaged by certain type of cleaners. So if you want to know what type of cleaners to use, I highly recommend to contact your provider. So that to come back to UVC lighting, then you've got to determine how long you will decontaminate thanks to UVC. The idea is that in order to determine the accurate time to decontaminate your enclosure, you've got to refer to the literature. And here, as example, I gave two examples. One for RNA viruses. I found this reference where David Little and José Luis Zacripanti determined that you need 12 millijoule per square centimeter of worktop to deactivate this type of virus. And Below that, you've got one example for Escherichia coli. So depending on the destruction rate you're looking for, I gave you different amounts of UV that is needed and the time that is necessary to deactivate the DNA or of Escherichia coli thanks to the UV lamp. Knowing that here, that's an example for Captair BIO 321 with an intensity of light of 0.08 millijoule per centimeter per second. What you can see here, the timer, the UV timer of the Captair BIO SMART can be set between 5 minutes and 30 minutes. And according to these two references, you can see that most of the time, 5 minutes of insulation, thanks to the UV lamp, is enough to decontaminate your enclosure. So Captair BIO SMART, they are totally designed for pre-PCR, thanks to the ventilation when it's needed, and the ability to decontaminate with accurate lamp at 244, 54 nanometers. I just want to focus on the idea that these enclosures are not designed for work with pathogenic organisms, but when DNA is extracted from the virus, it's no longer pathogenic and there is no risk to handle it into a PCR. So that's very important to understand that. Other features, so all Captair BIO SMART are designed in order to improve the cleanability, and the two worktops, the one in stainless steel or the one in Trespa Top Lab Plus, are manufactured in order to have no square corner. You can sweep it very easily in order to avoid any accumulation of dust or contamination in the corners. The front door and the post are manufactured with 10 millimeters UV resistance PMMA. And the assembly is optimized in order to avoid any leakage of UV out of the enclosure, because you know that UV is very dangerous for the user. So, and the front door is equipped with a switch. When you close it, so you're sure to avoid any UV leakage, and you can turn on the light with no risk for the user. All Captair BIO SMART are equipped with a slanted front door for better ergonomics. I talked about the noise before. The front doors is another part of the ergonomic, and I can also talk about the internal LED lighting. So we designed this enclosure to be totally the ergonomics for the user who will spend a lot of time per day in front of the enclosure. The choice of the PMMA of the walls, polymethyl methacrylate that you use for the slanted doors, is also selected because 10 millimeter thickness can stop beta rays, and sometimes DNA or RNA are marked with radioactive phosphor at low dose, and that's so the thickness of these PMMA panels is selected to be sure that there is no escape of these rays out of the enclosure. Each unit is equipped with 2 modes, one UV decontamination and handling. So you've got a cycle between the time where you decontaminate, everything is closed, there is no sample in it, just to be sure that when you will start the handling, everything is decontaminated. And during the handling, so the unit is vented or not. We'll see that we've got different options for that. But you must be sure that there is no decontamination thanks to these 2 modes. They are equipped with high efficiency UV bulbs centered on 254 nanometers with no risk of emission of ozone. and that's also very important for end user. And the internal LED lighting generate daylight lightnings at 900 lux. The units are simple to operate. We want the user to focus on their application, and it's also very easy to assemble or to maintain by yourself if needed. So we've got three different types of bio, two BioSmarts, the 321 and the 391. The 391 is a little bit larger. It's a 1 meter large enclosure, so that might be a little bit more comfortable if you've got more samples. But also the internal insulation, UV insulation, is a little bit higher than on the Captair BIO SMART 321. Both units, the 321 and the 391, are both equipped with UV lamps and HEPA filtered or optional HEPA filtered to ensure air cleanliness into the enclosure. We also sell what we call the Captair BIO 320. This enclosure is not vented. It's designed to be installed in clean rooms where all the room is already dust-free. In that case, you do not need to have any HEPA filters on your worktop, but it's equipped with high-efficiency UV lamps, are the same as the one used in the 321, and that's got almost the same dimension. So to conclude, that's very important to understand that PCR applications are very sensitive to contamination, and from the extraction to the amplification, that's very important to be well organized with three different workplaces. One for the extraction, and if the sample is pathogenic, it's important to do it in a BSC. The second one, where you mix your sample with primers, with nucleobases, and what we call pre-PCR, must be done in a pre-PCR workstation. Thanks, as example, the Captair BIO SMART 321, 391, or 320, and then the amplification itself must be done in thermocycler, and that's also another place. And when you select a PCR workstation, it's also very important to ask your provider to guarantee a perfect UVC insulation thanks to the accurate UV lamp with no release of ozone. So thank you for your attention.